Okay, think about this for a second. You lived an entire, complex, vibrant life before the age of 3. You had a distinct personality, you had strong preferences, you had real experiences, and yet you have absolutely zero memory of it. None. Today in this explainer, we are going to explore exactly why you can't remember being a baby, and I promise you, the answer is way more fascinating than you might think.
So let's jump right into part 1, the mystery of missing memories. Okay, let's dive into this. To really understand what's happening here, we first need to unpack the core paradox of our completely blank first 3 years. Think about the sheer volume of data your brain processed in those early days. You opened your eyes for the very first time. You heard a voice. You tasted food. It was literally the most action-packed period of learning in your entire life. So it begs the ultimate question: where did your first years go? Because despite all of those massive life-altering milestones, not a single moment of that was recorded in a way that you can recall today. It's just a total blackout. Now, most people just assume the answer is super simple, right? Like, oh, the baby brain just wasn't ready yet. But science has actually recognized this as a specific, targeted phenomenon for over a century. Sigmund Freud coined the term infantile amnesia way back in 1905 to describe how these early childhood memories are completely lost by adulthood. He recognized this wasn't just typical run-of-the-mill forgetting, and as modern science has revealed, the reality of this amnesia is so much more complex than just having a weak baby brain. Because here is the first major twist. Baby brains actually can form memories. We know this for an absolute fact. Let me walk you through this brilliant 1980s experiment by psychologist Carolyn Rovi Collier. It's incredibly elegant. She tied a ribbon from a baby's ankle to a mobile hanging above their crib. The babies quickly learned that kicking made the mobile move, and naturally they loved it. But here's the crucial part. When she brought those same babies back days or even weeks later, they remembered. They started kicking immediately. Even 2-month-olds held that memory for days, and 6-month-olds held it for weeks. So infant brains absolutely can learn, store, and recall information. The memories were there, which means something else came along and destroyed them.
Which brings us to part 2, the hardware problem. To figure out what actually happened to those memories, let's look at the physical brain itself. Your brain relies on very specific biological machinery to hold onto the past. The hippocampus is basically your engine of memory formation. It takes a lived experience, like a birthday party or a walk in the rain, and it encodes it. In adults, the hippocampus works with the prefrontal cortex to tag and store those episodes. But in infants, this system is severely underdeveloped. And the absolute most critical part of this is the dentate gyrus. Think of it as a gateway for new memories to pass into long-term storage. Well, that gateway simply isn't fully wired up until you're between 2 and 4 years old. So your infant brain could form short-term memories, like kicking the mobile, but it physically couldn't move them into the permanent adult vault.
But the story doesn't end there. Let's look at part 3, the rewiring paradox. So the hardware was faulty. Case closed, right? Actually, not even close. The hardware problem is only half the story, and what comes next is incredibly counterintuitive. Back in 2014, neuroscientists Sheena Jocelyn and Paul Franklin in Toronto tested a hypothesis that sounded almost absurd. They asked, what if the process that builds your brain is exactly what destroys your memories? They looked at neurogenesis, which is the rapid production of new brain cells. And this brilliantly illustrates their point. When the researchers artificially increased this explosive brain growth in adult mice, those mice actually forgot previously learned things. And when they intentionally slowed down neurogenesis in infant mice, the infants held onto their memories much longer than normal. Which brings us to this profound conclusion. The brain kept building new rooms and tearing down the old walls in the process. Give yourself a second to visualize that. Your baby brain wasn't too weak to hold memories, it was simply too busy growing. Every single time a new neuron integrated into an existing circuit to build the brain you'd use for the rest of your life, it disrupted the connections that were already there. That explosive growth literally overwrote your earliest experiences. Now, let's pivot a bit for part 4, the missing you. Because hard neuroscience really only gets us so far. There's a deeply psychological dimension to this black hole in our past, and it requires us to get a little philosophical. To form an autobiographical memory, a memory you can actually replay in your head like a movie, you need a main character. You need to know that you exist as a distinct person. Let's break down a classic 1990s test by developmental psychologists Mark Howe and Mary Courage. It's famous. You put a little dot of rouge on a baby's nose and place them in front of a mirror. Before 18 months of age, the baby usually just ignores it, or treats the reflection like it's another kid entirely. But right after 18 months, something magical happens. They reach for the mark on their own face. They finally recognize the person in the mirror is them. And here is the absolutely crucial point. The birth of self-recognition closely tracks with the earliest age at which autobiographical memories can actually form. You can't remember being a baby, in large part because there was literally no you yet to experience those memories. There was no internal narrator packaging those sensory inputs into a story that belonged to a specific individual. Which brings us nicely to part 5, the architecture of language. So we have the hardware, the rewiring, the sense of self, and now we introduce the fourth mysterious layer, language. Because as developmental psychologist Catherine Nelson discovered, words do a lot more than just describe our past. I love this metaphor right here. Language gives memory a skeleton. Without it, experiences are like water with no container. Before you could speak, your experiences were encoded as raw sensory impressions. You felt textures, you saw light, you felt big emotions, but without words to organize them, those pre-verbal impressions simply washed away. They existed entirely in the moment, and then they were just gone. Now, what's really interesting about this slide is that language and storytelling aren't just theoretical ideas. Look at this data from Cornell psychologist Chi Wong. The age of your earliest memory actually changes depending on your culture. In Western cultures, where parents are constantly narrating experiences and asking kids questions, earliest memories usually start around 3.5. But look at the Maori of New Zealand, a culture with a massive, rich oral tradition that places extraordinary emphasis on personal history. Their earliest memories reach all the way back to 2.5 years old. Meanwhile, in East Asian cultures, where early narratives focus a bit less on the individual, memories start closer to 4. The cultural storytelling you are exposed to literally shapes how far back your own mind can reach. Isn't that wild? All right, let's wrap this all up in part 6, the cost of becoming you. We've uncovered some truly incredible mechanisms in this explainer today. Let's rapidly pull it all together. First, your hippocampus simply wasn't ready to build long-term memories. That physical gateway, the dentate gyrus, was still under construction. Second, even when your brain started trying to save files, that massive flood of new neurons required to build your adult brain physically tore through and overwrote the memory circuits that held those early experiences. Third, from a psychological standpoint, the main character hadn't arrived yet. There was no continuous concept of self to anchor those early experiences to. And finally, fourth, there was no language to give those raw, watery sensory experiences a structure that could actually survive. It wasn't just one failing, it was everything, all at once. Your brain created a black hole in your past because it was too incredibly busy doing the heavy lifting of becoming you. And sadly, that required destroying the temporary drafts of the person who came before, which leaves us with this final, deeply profound question to ponder. If you had no continuous sense of self, and the brain that held your earliest experiences physically rewired itself beyond recognition, is the baby in your old photos actually you? Or is it someone else entirely? Someone who lived in the exact same body, but whose mind was literally disassembled and rebuilt, neuron by neuron, to make the person watching this explainer right now. Take that thought with you next time you look through a family photo album. Thank you so much for learning with me today, and I'll catch you in the next explainer.